Hey everyone. In this video, we are going to talk about multiplying square roots or radical expressions. So let's go over first a quick rule that we're going to need. So if we have the square root of a times b, we can rewrite this as the square root of a times the square root of b. I think we've already seen this, but this is just a quick review. Okay, and very similarly for division, if we have the square root of a divided by the square root of b, this can be rewritten as the square root of a divided by b. Okay, so this is all assuming that both a and b are positive numbers, so they're greater than, we'll say greater than 0. Okay, so let's go ahead and get started here with a few examples. Here we have the square root of, or 2 times the square root of 75 times the square root of 25. Okay, well, one of the things we notice right away is that the square root of 25 can be immediately reduced to 5. Okay, so we can rewrite this as 2 times the square root of 75 times 5. Okay, and then we can combine the whole numbers here. 2 times 5 is 10, so we have 2 times the square root of, or up to 10 times the square root of 75. Okay, but we can do a little better with the square root of 75. The square root of 75 we can write as the square root of 3 times 25. So if we do that, we get the square root of 3 times 25 times 10. And using our rule we have up here, we can go ahead and split up this square root. So we have 10 times the square root of 3 times the square root of 25. And the square root of 3 is about as simple as it gets, so we're going to have to leave that alone. But the square root of 25 we can simplify to 5. So we have 10 times 5 times the square root of 3, which is just 50 times the square root of 3. Okay, now let's look at this one. Here we have 2 times the square root of 12 times the square root of 48. Okay, so neither one of these immediately simplifies to a whole number, so we're going to have to do a little more work here. So we have 2 times the square root of 12. Well, the square root of 12 can be written as the square root of 3 times 4. Okay, and the square root of 48 can be written as the square root of 3 times 16. Okay, so that's helpful. So we can have, once we split these up using our rule, our multiplication rule, we have 2 times the square root of 3 times the square root of 4 times the square root of 3 times the square root of 16. And so now we have a couple of square roots of perfect squares, so we can go ahead and simplify those. So we have 2, the square root of 4 is 2, so we have 2 times 2 times the square root of 3. And the square root of 16 is 4, so we have 4 times the square root of 3. Okay? And we can rewrite this as 2 times 2 times 4 times the square root of 3 squared, because we have the square root of 3 times the square root of 3. But that just undoes the square root, so really we have 2 times 2 times 4 times 3. Okay? So 2 times 2 is 4, times 4 is 16, so we have 16 times 3, which is just 48. Okay, how about 3 times the square root of 45 times the square root of 50? Okay, well, again, neither of these can be simplified immediately to a whole number, so we're going to have to do a little bit of simplification. That's not too bad. So this first one we can rewrite as 3 times the square root of 9 times 5. And then we have the square root of 50 can be written as the square root of 2 times 25. Okay, so if we split everything up here, we have 3 times the square root of 9 times the square root of 5 times the square root of 2 times the square root of 25. Okay, so if we reduce the ones we can reduce, we have 3 times square root of 9, which is 3, times the square root of 5, times the square root of 2, times the square root of 25, which is 5. Okay, so if we multiply all of our whole numbers together, we get 3 times 3 is 9, times 5 is 45, times the square root of 5, times the square root of 2. And if we combine the square root of 5 and the square root of 2 together using our multiplication rule, we'll have 45 times the square root of 5 times 2, which is 45 times the square root of 10. And the square root of 10 is about as simple as you're going to get it. Okay, now let's look at this one here, where we have the square root of 3a to the 7th times the square root of 6a. Well, right away, we're going to use our multiplication rule. We're going to combine everything under one square root. So if you don't know what else to do, that's a good place to start, because maybe you can simplify it once all the numbers are together. So if we multiply everything under one square root, we will have 3 times 6 times a to the 7th times a. Okay, so then we have the 3 times 6 is 18, so we'll have the square root of 18. And a to the 7th times a is a to the 8th. So we have the square root of 18a to the 8th. Okay? And 18 we can write as 9 times 2. All right? 9 is a perfect square, so that's helpful. So we have the square root of 9 times 2 times a to the 8th. And now let's go ahead and split all of these up. So we'll have the square root of 9 times the square root of a to the 8th times the square root of 2. The square root of 9 is just 3. And then I'm going to rewrite this square root of a to the 8th as actually raising a to the 8th to the 1/2. We're going to multiply that times the square root of 2. Okay, remember, because anytime we have the square root of a number, right, so we have the square root of a, that's equal to the square root, this is a different letter, we have a in the problem. We have the square root of x, that's equal to x to the 1/2, right? So I think this makes it easier when you're trying to deal with exponents, because it shows you how you can simplify them a little easier. Okay, so remember, if you take an exponent to another exponent, here we have a to the 8th raised to the 1/2, you just multiply them together. And 8 times 1/2 is just 4, so this becomes a to the 4th, and then we have that times the square root of 2. And that's about as simple as you're probably going to get this one. Okay, now let's look at this next one. Here we have the square root of 2 times a to the 5th times the square root of 18 times a squared. Okay, so let's see what we can do here. So now, if we want to combine, we can start by combining everything under 1 if we don't know what else to do. Okay, so we have the square root of 2 times 18 times a to the 5th times a squared. Okay, so if we combine all of that together, we're going to end up with the square root of 36 times a to the 5th times a squared. That's going to give us a to the 7th. Okay, and we can split these up. So we have the square root of 36 times the square root of a to the 7th. Okay, so the square root of 36 is just 6, so we have 6 times the square root of a to the 7th. And a to the 7th is not something that we can quickly reduce using a square root here, okay? So we need to rewrite this as, and the reason we can't do that is because if we raise something to a half power, it'd be nice if the exponent was even, because then we could just divide by 2 and it becomes a nice clean number. So let's rewrite this as 6 times the square root of a to the 6th times a, okay? That is a to the 7th, but a to the 6th is an even number, and it should be easier to, right? The 6 isn't the 6 on the as the exponent for a. 6 is an even number, so it should be easier to reduce. So we have 6 times the square root of a to the 6th times the square root of a. Okay, and this is equal to 6 times a to the 6th. We're going to raise this to the 1/2, right? We can rewrite the square root as to the 1/2 times the square root of a. Okay, and from there we get 6 times a to the 3rd times the square root of a. And that's probably how Alex is going to want you to input that into the program. Okay, I sort of think, this is just my opinion. I mean, I guess it depends on what you want to do with the problem. And depending if you have a more complicated problem and you're going to use a technique like this, If on my test, if it was a test that I was giving you, I would be okay with you leaving it as 6 times the square root of a to the 7th, but Alex, I think, wants you to reduce it further. I think this is probably the neatest expression for it. So, but there may be a time where you want to write it as 6a to the third times the square root of a. Maybe you have more a's in your bigger problem, and so it'd be easier to reduce some of those. But my thought would be you can deal with that if you need to. But really, I would consider anything from here to here as a valid answer. Anything along the way here would be valid. Okay, now let's take a look at this next one. We're going to use a little bit of the distribution property. A little review here. Remember, that means we're going to distribute this from here to here. Let me turn off my notifications here. Okay. All right, so what we're going to do here is we're going to use the distribution property, which we've seen before. So we're going to start by distributing this 2 times the square root of 6 to the square root of 7 and then to minus the square root of 2. So we'll have 2 times the square root of 6 times the square root of 7 minus 2 times the square root of 6 times the square root of 2. So let's see what we can do to simplify here. I don't know if this is going to turn into something that we could nicely simplify, but we'll see what we can get done, right? So let's start by combining this first term here into one square root. So we have 2 times the square root of 6 times the square root of 7, which is the square root of 6 times 7, which is the square root of 42. Okay, and then here we have minus 2 times the square root of 12. Okay. So let's see what we can do with this. Okay. So I'm wondering if 42 is probably as simple as you're going to get on that one. I don't know if we can write that as a product of two numbers or one of them as a perfect square. And one way to check this would be to just write the factors of 42. So let's just check that out. Pretty tired, so if I'm missing this, I blame being tired. But okay, so factors of 42. Okay, so we have 1, we have 2, we have 3. I guess we should write out 1 times 42. I guess we could do 21 for 2. Okay, and we have 14 for 3. Okay. Okay, and then we have 6, and obviously 6 and 7, which we had from before. Okay, and I think that's about it. So none of these are perfect squares. And what that means is we can't write this as a product of perfect squares. So therefore, we are going to leave 2 times the square root of 42 alone. Okay, that's fine. But 12 we can simplify. We've already done that. So we can rewrite this as 2 times the square root of 42 minus 2 times the square root of 4 times 3. And we know that 4 is a perfect square. So we have 2 times the square root of 42 minus 2 times the square root of 4 times the square root of 3. All right. And then we have 2 times the square root of 42 minus 2 times 2, which is 4 times the square root of 3. And I think that's about as simple as we are going to be able to make this one. Okay, let's look at one more here, like it. We have the distribution property. Here we have 4 times the square root of 3 times the square root of 3 plus the square root of 14. So let's go ahead and distribute this. So if we have the square root of 4 times the square root of 3, we're going to multiply that by the square root of 3. That will work out nice. And then we have 4 times the square root of 3 times the square root of 14. Okay, so let's do some simplifying. So what we'll notice right away is that these two here, square root of 3 times the square root of 3, this is actually the square root of 3 squared, which means we can just undo that square root, and that becomes 4 times 3. And then the square root of 14 times the square root of 3, we can write that as the square root of 14 times 3. or 3 times 14, either way. Okay, and that's going to give us 12 plus 4 times the square root of 42, and we already established that we can't simplify that any further. So this is probably about as simple as you're going to make this problem, okay? I don't think you're going to get a whole heck of a lot better than that. Okay, so now let's look at this next one. Here we have 2 times the square root of x minus the square root of 5, and we're squaring that whole expression. So just as a reminder, one thing, this is something I see on every, I see this on every test, is you cannot just distribute this square to each of these, okay? You have to rewrite this for what it actually is. We're squaring the whole expression. So this is actually 2 times the square root of x minus the square root of 5 times itself again. So we have 2 times the square root of x minus the square root of 5. And now what we have to do is we have to do the FOIL technique for this. So we do our firsts, so 2 times the square root of x times 2 times the square root of x. Okay, so if we do that, we'll have 4, and then the square root of x squared. That's nice. And then we have, if we do these two, we have our, sorry, I'm getting that order here. So we have our firsts, and we have our outers. So we have 2 times the square root of x minus the square root of, times the square root of negative 5. So we have minus 2 times the square root of x, square root of 5. And then we have minus 2 times the square root of x times the square root of 5. And then we have plus the square root of 5 squared. Okay, so then we have, okay, so here we have the square root of x squared. That just undoes the square root. So we have 4x, and then we have 2 copies here of minus 2 times the square root of x times the square root of 5. So we'll just have minus 4 times the square root of x times the square root of 5. And then the square root of 5 squared just undoes the square root, so we have plus 5. And I believe that is probably about as simple as you are going to make that. Okay, now I want to briefly introduce something that we're going to use here in a little bit. And we're doing division, but this would be a good place to do it. This is something called a conjugate. Okay, so if you have something like A plus B, the conjugate of A plus B is A minus B, okay? So you're only changing that second sign here. So you go from a positive B to a negative B, okay? And this gives you a really nice property here. It gives you a really nice property where you're able to sometimes deal with more complicated equations by taking advantage of this conjugate property here, right? So here, if we have another little fact that might make this a lot easier, if we have A plus B times A minus B, I'm going to work this out and show you how we can actually use the conjugates property here to be able to make fairly complicated foiling problems into just a quick formula that we can remember, okay? So if we FOIL this out, we get A squared minus AB plus AB minus B squared, okay? The minus AB and the plus AB, these cancel, and we're left with A squared minus B squared. So anytime you see something that you're foiling something together, and you notice that it's a conjugate, like you're multiplying an expression by its conjugate, you can just utilize this A squared minus B squared. You don't have to go through the whole foiling process, okay? So let's use this for this first problem here. Here we have the square root of x plus the square root of 5 times the square root of x minus the square root of 5. So we notice that the signs for the square root of x, they're both the same. They're both positive. But the signs for the square root of 5 are both different. So we have plus the square root of 5 and minus the square root of 5. Okay? So what this means is we have a conjugate multiplication problem here. Okay? So we can go ahead and go straight to our formula here, a squared minus b squared. So if this is a and this is b, okay? If the square root, if the square root of x is a and the square root of 5 is b, then we can go ahead and rewrite this as the square root of x squared minus the square root of 5 squared, okay? But these just undo the square roots, so this just becomes x minus 5, and that is your whole expression. And if you want to see that this actually works in practice, you think that can't be that simple. It is. Let's actually just go through the process here. So if we did our FOILing, we would have the square root of x times the square root of x, okay? And then if we do our outers, we'll have the square root of x times the square root of 5. Then our inners will have the square root of x times the square root of 5. And then we'll have minus the square root of 5 times the square root of 5. Okay, so square root of x times the square root of x, that's the square root of x squared. So we'll just have x, okay, minus x, the square root of x times the square root of 5 plus the square root of x times the square root of 5. These will cancel. And then we'll have minus the square root of 5 squared, which is just 5. So it gives x times 5. So you can see that if you can memorize that formula, if you have conjugate multiplication, then you can just use a squared minus b squared. And especially with square roots, this goes very quickly, okay, because you're just undoing square roots. So we get, either way is fine, but you get x minus 5 as your final answer. Okay, let's look at one more. Here we have the square root of x minus 2 times the square root of 3 times the square root of x plus 2 times the square root of 3. Again, we notice we have a conjugate multiplication problem here, okay? We have square root of x minus 2 times the square root of 3. And then we have the same thing, but with a plus in the middle here. So we can utilize a squared minus b squared. So if we say that this is a and that this is b, we're going to end up with the square root of x squared minus 2 times the square root of 3 squared. Okay, square root of x squared, that just undoes the square root, and we get x minus 2 times the square root of 3 squared. But here we can distribute this because it's multiplication on the inside, it's not addition. So we have 2 squared, which is 4, and then the square root of 3 squared is just 3. So 4 times 3, or we have x minus 12.